we're going to look at geometric sequences. So we're going to see how we can get from one terms to another. So I look at my numbers 5, 10, 20, and 40. I know I can get 5 to 10 by multiplying by 2, 10 to 20 by multiplying by 2, and 20 to 40 to multiplying by 2. So my pattern is multiplying by 2. To find my pattern, what you would do is you would take your next and divide it by the previous now versus subtraction. So 10 divided by 5 is 2. 20 divided by 10 is 2. And 40 divided by 20 is 2. So our two types of formulas, again, are recursive and explicit. So to find the recursive, we have a sub n equaling a sub n minus 1 times r. So a sub n equals a sub n minus 1, so this is your previous term, times your r, which is your common ratio, and in this case it is 2. To find the zero term, you're going to take your first term in your sequence, in this case for us it's 5, and then divide it by your common ratio, which is 2. So the zero term would be 5/2 or 2.5. Again, the zero term is when n is equal to 0. Your explicit formula is a sub n equals a sub 1 times r to the n minus 1. So your term number, your first term in your sequence, your common ratio, and then your term number. So in this case, we would have a sub n equaling a sub 1 times 2, that's our common ratio, to the n minus 1. Okay, let's look at the next one. Here we have 0.4 to 0.04. I would see that maybe I have to multiply this one by 0.1. So this is a little bit tricky. So if we can't visually see it, then jump to this one, excuse me, jump to this one and do your divisions. So from 0.04 to 0.004, again I'm timesing it by 0.1. To 0.004 to 0.0004, again I'm multiplying by 0.1. And this could honestly be just be a guess if you can't see it. So our pattern, again, is we are multiplying by 0.1. So if we can't visually see it, then do our little formula. Take your next and divide it by the previous. So 0.4 divided by 0.04 would equal 0.1. 0.004 divided by 0.04 equals 0.1, and 0.0004 divided by 0.004 equals 0.1. Okay? So we know it's geometric when we have to use multiplication. We know it's arithmetic when we're doing addition or subtraction. So our recursive formula is going to be a sub n equaling a sub n minus 1 times our r, which is our common ratio, which we have is 0.1. To find the zero term, so when n is equal to 0, you're going to take your first term, which is 0.4, and we are going to divide it by 0.1. And so 0.4 divided by 0.1 will give us 4. Again, please use your calculators if you need them. Explicit function. This is going to be a sub n equaling a sub 1 times your common ratio, which is 0.1, to the n minus 1. You can put a 0 in front of your decimal if that is helpful. Okay, let's look at the next one. We have 7, 21, 63, 189. So 7 to 21, I'm going to times by 3. 21 to 63 times by 3 times by 3. So this is a pattern that I can see. But if we can't see that pattern, then please go to your third box and do your division. So our pattern is we're going to multiply by 3. So 21 divided by 7, so that's your second term divided by your first term, would give you 3. 63 divided by 21 would give us 3, and 189 divided by 63 gives us 3. So that is our fourth term divided by a third term, our third term divided by our second divided by our first, our next divided by our previous. So your recursive formula would give you a sub n equaling a sub n minus 1 times your common ratio, which is 30. That common ratio, again, is your pattern. To find your zero term, you're going to take your first term in your sequence, which is 7, divided by the common ratio, which is 3. So your zero term would be 7/3. Your explicit function would be a sub n equals a sub 1, which is 7, times 3 to the n minus 1. And looking up here, it looks like I forgot to put my a sub 1 in both of these. So if we go back up to this, the top one would be a sub n. My first term in my sequence would be 5 times 2 to the n minus 1. Here I would have a sub n. My first term is 0.4 times 0.1 to the n minus 1. I apologize. Okay, because we know the a sub 1 term, the first term that we see in our sequence. Last one. So we have 9 to 18, times it by 2. Okay, 18 to 36, it's a times by 2 as well, and 36 to 72 is a times by 2 as well. So our pattern is we're going to multiply by 2. If you need we need to check it algebraically. Again, if we can't see it here, just jump to this box. So you take your next, which is 18, your second term, divided by your first term. 18 divided by 9 is 2. Your third term is 36 divided by your next term, which is 18, and you get 2. You have your fourth term, which is 72, divided by your previous term, which is 36, and that as well gives you 2. We have to have the same common ratio in order to be geometric. If the ratio changes, then we do not have a geometric sequence, and therefore you do not have a recursive or an explicit formula. Your recursive formula for this is a sub n equaling a sub n minus 1, so that previous term times 2. Your zero term, you take your first term, which is 9, divide it by 2, and you would have it equal 9/2. Your explicit formula would be a sub n would equal your first term in your sequence, which is 9, times your common ratio, which is 2, raised to the power of n minus 1. So let's kind of recap. If I'm a geometric sequence, my pattern is going to multiply by a number. If I am arithmetic, then I'm going to add or subtract a number. To be a sequence, though, you have to have the same common difference or the same common ratio. In both cases, for recursive, you have to know the previous term in order to find the next term. With explicit, you only have to know the term number that you're looking for. So explicit will allow you to find a higher term number a lot quicker than the recursive function.